for small customer, one that has queries optimized for a large data set, and support and maintain two product lines. Are the optimizations you're kind of bringing forth today worth it?
On average, I would say probably not. I think in general, when you have very small data sets, assuming you do not have a tiny machine with no CPU and no memory, in general, the difference between doing a full table scan and index scan for a table with 1,000 rows, is fractions, in the milliseconds, some number of milliseconds, certainly under a second. It's not going to matter. So you want to tune for where you project. You want to basically tune for the worst case scenarios, because in reality, if your table is small, or these two tables have a few thousand rows, as your company grows, the difference between this is noise compared to whatever you're going to do once you pull that data, once you're in the application doing calculations, just moving that data from, maybe if you're running, HTTP stack, and from your app server out to create whatever pages you have over the network to where your users might be. You might end up spending way more time just in the latency of the network and all that stuff that all your SQL tuning is for naught. You may tune only from the standpoint that it may not get better response times for the end user, but you may be consuming fewer resources on your server, so you can actually load more data, more application environments. If you're, for example, hosting cloud, and you're going to multi-tenant with many customers, okay? If you can reduce your, tune SQL and tune your application, and we'll talk about that, of course, also, it may not produce any faster response time, net because of all the noise going out over the network if you're a web application or just construct your HTML pages or whatever kind of widgets and controls you have. But you may be consuming fewer resources on the database side or in your app server. You may be able to stand up on a particular size box instead of 6 customers, you may be able to stand up 7 or 7.5 or some number of thousands. Instead of standing up 10,000 users, you may be able to stand up 12,000 or 11,000 users. 12. And so that's where you're going to get the savings. It may not be anything that an end user will ever see or know, but you working your IT department will see the benefits. And so there's potential. That's why this is a worthwhile exercise, finding the most offensive things anywhere in your stack. Maybe on the server, may have nothing to do with the database. But it's probably worth it because you'll save your company money. Even at the end of the day, the end users don't see anything marginally faster or slower. And again, depending on the size of your data sets, we're talking about a handful of milliseconds. Maybe half a second or something. It's only the most offensive, bigger reports where you might cut it down from a minute to half a minute. That may have huge gains in terms of the end user experience. Those are possibilities. But it's a good set of questions.
One more. Just kidding.
Oh, you have 2 more. You can burn your time out, that's fine. So here's just a couple more examples. We'll talk, and then we'll do the break right after I go through these, I think. So you can replace lots of different statements. And these are just, again, lots of different examples. So where I'm selecting, here's a where exists clause, which in general where exists aren't bad. They're generally really good. But frankly, what you can do, I'm just doing this to show you sort of the concept is, and here you have, from a table, and you do inquiry from a table, you can actually replace the table in the from clause with an actual query. So you're actually creating not a temporary table, but I won't talk about it because it's one of the questions later. I do have a quiz. You can actually create this in memory, execute it once, it produces a data set, and then join them together. So instead of having to do a parent and a child and a sort, I'm actually doing queries. So that's just a nice, powerful mechanism within Oracle, SQL Server. NC SQL allows you this kind of grammar. Here's an example where you have where not exists from tables, and you're doing it correlated. So you can just do a query against 2 tables and do an outer join with a plus where the second row is null. So instead of not exists, you look for the second row ID is null. So again, that's just a nice fast way, speeds up these kind of queries. I could select star or column 2 and I'm pulling data, and here I'm doing a max. So instead of doing it inside, I'm actually doing it at the parent, so I only have to execute it once. I don't have to execute it every time for every row here. So here, for every row in A, I'm checking column 2, I'm executing this again. So I'm basically, if there are 1,000 rows in table A, I'm executing this 1,000 times. Whereas here, I'm really only executing it once and comparing the 2 data sets, so I'm doing basically a merge join there. Yes?
Plus signets write outer join.
Which one? This one?
Yeah.
Yeah, that's an outer, yeah, sorry, the syntax, that's for an outer join, yeah. Right, Oracle allows you to use the plus sign instead of saying outer join, is what it is, just, it's a syntactic sugar we used to say. We already talked about the minus, where you have that whole sort. And so here's just so basically another example, where you could basically replace by, the criteria, and again, using the outer join to solve it. And here's just an example. This is a very simple mistake. Made mistakes, that's right. Here's something very simple scenario, which is very common, which people don't realize. So if I'm selecting customer and then say discount percent divided by 100, and sum the amount from sales, and I want to group by customer and discount percent. Well, it turns out, because I'm doing an order by 1 and 2, which means I'm doing an order by customer and discount percent over 100, it turns out I have to do 2 sorts. First, I'm sorting for the group by, because I'm doing customer and discount percent, and then I'm ordering by customer discount percent divided by 100. So instead, let's group by that same criteria. I can use the results of 1 sort instead of having to do 2 separate sorts. That's a very subtle kind of scenario, but because I actually have different criteria, here it's customer discount percent, and here it's customer and discount percent divided by 100, I'm doing 2 different sorts. Now, we're smart enough to know that discount percent divided by 100, again, they're linearly correlated, so you're going to get the same exact results, as it turns out. But here, we're sort of telling it, you don't have to figure out, and be smart in math or anything like that. So this would be much, much faster than this, because you've eliminated a whole sort, which in sorts, again, are being one of the most expensive operations. Timeout. Okay? So what I will do is I will stop right here, pause, because I told you I'd talk about Cartesian products. We'll do a timeout. Nick, you're on.
Just timeout?
Timeout. Anybody want to get bathroom, coffee, tea, anything?